listeners. You are welcome to the continuation of the physics tutorial class from your favorite student ScoreBooster, your online tutorial provider on JAMB, WAEC, NECO, and NAPTIP exam. For today's lecture, we shall be considering projectile motion, which is still a continuation of concept of motion. I am Bangbade AA. Now, before we continue, we need to consider the concept of motion under gravity, and this deals with the motion of an object under the influence of gravitational attraction. If we can recollect from our video 1, that is the video on linear motion, we discussed the equations of linear motion, which is summarized in this table, and from there we can derive the equations of motion under gravity. For example, the first equation of linear motion says phi equals u plus or minus at. Then we can derive the similar equation for motion under gravity by just replacing the acceleration a with acceleration due to gravity g. So if you replace a with g, then we have phi equals plus or minus gt. Then similarly, from s equals ut plus half at square, we can get the equation for the motion under gravity by replacing s with h and a with g, and that will give us h equals ut plus or minus half gt square. And lastly, from the equation that says phi square equals u square plus 2as, then we can derive the equation of gravity from its motion under gravity by replacing a with g, and that will give us phi square equals u square plus or minus 2gh. Now, on to projectile motion. A projectile is an object launched into the atmosphere and allowed to move freely under the influence of gravity. Examples of projectile include those that are in warfare, such as a fired bullet, a thrown arrow, a thrown spear, etc. The other category of the example of projectile are those that are used in sports warfare, such as a thrown javelin, a thrown shot put, a thrown discus. All of these are used in sport. Now, let's consider the diagram of a projectile motion. Now, it's usually represented by a parabola curve, and the part of a projectile is therefore called a parabola or a trajectory. A parabola or a trajectory. So from the sketch, we have the maximum velocity, which is represented by phi. Then you have the maximum vertical displacement, which is represented by capital H. That is the difference or the distance between the maximum height reached, the highest level reached vertically, and the horizontal. So the distance between the highest level reached and the horizontal ground is maximum height, which is usually represented by capital H. Then we also have capital R, which is range. That represents the horizontal distance covered by a projectile. So it represents the horizontal distance covered by a projectile. Now, let's go to terms in projectile. Just like I said earlier, the first term we shall be considering is the trajectory or parabola, and that is the path covered by a projectile when it travels. So that arc is called a trajectory or a parabola. Then, having understood the part of a projectile, which is a trajectory, we need to consider another term, which is maximum height. Maximum height h is the vertical distance traveled as measured from the horizontal plane. Mathematically, maximum height h equals u square sine square theta over g. Its unit is meter. Then the next concept we shall be considering is the range. Range is the horizontal distance traveled from the point of projection to the landing point. Range is the horizontal distance traveled from the point of projection to the landing point. Mathematically, range R is equal to u square sine 2 theta over g. U square sine 2 theta over g. That's the formula for range. Then we should note that we have maximum range when theta is equal to 45. So maximum range is achieved when theta is equal to 45 degrees. Then the unit of range is meter, usually represented by small m. Now the next time we shall be considering is the time to reach maximum height, usually represented by small t. It is the time to reach highest vertical distance above the ground. Mathematically, the time to reach maximum height t is equal to u sine theta over g. Its unit is second. Having understood the time to reach maximum height, the next term we shall be considering is the time of flight, usually represented by capital T. Time of flight is represented by capital T, while time to reach maximum height is represented by small t. Now, the time of flight capital T is the time required for a projectile to travel from point of projection to the landing point. The time required for a projectile to travel from point of projection or projection point to the landing point. Mathematically, the time of flight capital T equals 2u sine theta over g. Time of flight capital T is equal to 2u sine theta over g. Its unit is seconds. Now, let's consider the sample questions. And the first question we shall be considering comes from 2005, number 31. An object is projected from a height of 80 meters above the ground with a velocity of 40 meters per second at an angle of 30 degrees to the horizontal. The time of flight is dash. Then you are given option A to be 4 seconds, option B to be 16 seconds, option C to be 10 seconds, option D to be 8 seconds. Then you are given in brackets acceleration due to gravity g is equal to 10 meters per second square. Now on to solution. The first thing here is to write out the given parameters. And from the question, you are given the velocity u, which is 40 meters per second. Then you are given the theta, angle theta, to be 30 degrees, and acceleration due to gravity g to be 10 meters per second square. Then they ask us to find capital T, which is the time of flight. Now, in solving this, we have to recall that the time of flight capital T is equal to 2u sine theta over g. And when we substitute, that will be 2 times u, which is 40, sine theta, which is 30 degrees, divided by g, which is 10. So sine theta, 2 times 40 is 80, times sine 30, which is 0.5, divided by 10. So 80 times 0.5 will give us 40. 40 divided by 10 will give us 4 seconds, making option A to be the correct answer for this question. Now, the next question we shall be considering comes from 2009, number 8. And the question goes thus: a bullet fired vertically upward from a gun at 2.0 meter above the ground reaches its maximum height in 4.0 seconds. Calculate its initial velocity. Acceleration due to gravity g equals 10 meter per second square. Then you are given options. Option A to be 10 meter per second, option B to be 8 meter per second, option C to be 40 meter per second, option D to be 20 meter per second. Now on to solution. The first thing is to write out the given parameters. And from the question, we have to take note that at maximum height, that means the object is no more moving. So the final velocity there will be 0. It will first stop before starting coming down. So at maximum height, the velocity is 0. Therefore, our phi in this case, which is final velocity, will be 0. So our initial velocity u is what they ask us to find. Then you are given the time to reach maximum height, that is small time t, to be 4.0 seconds, and the acceleration due to gravity g to be 10 meter per second square. Now we have to recall that phi equals u plus or gt plus or minus phi equals u plus or minus gt. So that is the first equation under the motion under the gravity. So since the object is moving against the gravity, is moving up, then we'll consider minus. But if it's coming down, which is towards the gravity, it will be plus. Therefore, for this case, we use phi equals u minus gt. Now our phi will be 0 at maximum height, which is now equal to u, which they ask us to find, minus g, that's acceleration due to gravity, which is 10, times t, which is 4 seconds. So we can transfer minus 10 times 4 to other side. That will give us u equals 40 meter per second, making option C to be the correct answer for this question. The next question we'll be considering comes from 2015, number 8. And the question goes thus: a projectile is fired from the ground level with a velocity of 300 meters per second at an angle of 30 degrees to the horizontal. Calculate the time to reach the maximum height. Then g equals 10 meters per second square. You are given the option A to be 25 seconds, option B is 30 seconds, option C is 20 seconds, while option D is 15 seconds. Now on to solution. The first thing is to write out the given parameters. And we are given the initial velocity u here to be 300 meters per second, and the angle theta to be 30 degrees, while acceleration due to gravity g is 10 meters per second square. Then we have to get small time t, that is the time to reach maximum height. So using the formula for small time t, which is equal to u sin theta over g, our u is now 300 sin theta, which is 30 degrees, divided by g, which is 10. So that will give us 30 times sin theta is 0.5 divided by 10. So that will be 300 times 0.5 is 150 divided by 10. That will give us 15 seconds, making option D the correct answer. Now let's consider the UTME practice question. And the question we are having here comes from 1994, number 4. And the question goes thus: an object is projected with a velocity of 80 meters per second at an angle of 30 degrees to the horizontal. The maximum height reached is dash. So option A is 20 meters, option B is 80 meters, option C is 160 meters, while option D is 320 meters. So for this question, the expected answer is 80 meter, which is option B. Then you can use the formula maximum height equals u square sin square theta over 2g. Our next video will be on simple harmonic motion with sample questions and solutions from UTME. I urge you to please subscribe to our YouTube channel, like and share our videos, as we promise to be bringing you more interesting presentations and lectures on UTME related subjects. Thank you.